It's up to you, Ronnie.
Sounds good. Thanks for the intro, and happy to meet everyone. So let me share my screen and kind of explain what this is all about and how come I started being so interested in continuous feedback and OpenTelemetry and so on. So just a little bit of background about myself. I'm a developer for the past 25 years, perhaps, but kind of oscillated a lot between different roles in engineering teams. I was kind of too curious about the why to be, just in the code. So I went and became a little bit of a product manager, and then I was missing coding. So I went back to be a coder, and it was kind of my personal tragedy of never quite seeming to find one fit. So I ended up doing all sorts of weird made up jobs that kind of allowed me to combine the various elements. And I've always been very fascinated with development processes in general, and kind of why do we think something works? Why doesn't it work? How do we actually improve the development cycle? And it is kind of through that lens that I came across the concept of continuous feedback, which I kind of see as a gap in how we write code today. And to kind of explain more about that, I want to start with maybe a story that is very kind of indicative of the problem as I see it. And this is a story of a developer from my team. We're going to call him Bill. And Bill is charged with doing something that we're all very used to doing, which is needs to develop a feature, update some code, and put it into production. And when I got started, that job was rather easy. So 20-something years ago, we used to kind of develop, package it really nice, and then send the code over to the guys across the hall in the QA department, and they would take it from there. And this is essentially where my responsibility as a developer ended, unless I got some rejects or bugs from production. Things changed, and today Bill is kind of top of the line developer. He's writing unit tests, he's planning and writing some of the integration tests. He's even involved in the deployment. He knows when he needs to update the Helm chart or even the Terraform file. He's a full kind of end-to-end developer. But the question is, and this is kind of something that I repeatedly noticed, what happens the minute after he pushes this code to production? So any guesses, by the way? You feel free to kind of write in the chat what you would do the minute after you pushed your code into production. Let me see if I can actually view the chat here. Walk away. Yeah, yes, exactly. So as much as I tried, it was always kind of moving on to the next feature. So it got to several situations that I witnessed firsthand where, the code wasn't getting even, it wasn't even getting executed. So even that minimal check of kind of whether the code that I created was running, whether anybody was using it, whether it was kind of, I can think of other things to check. Is it improving life for everyone? Is anyone using it? Are there any changes I should be worried about? So all of these questions are great questions that I really wanted Bill to ask, but try as I might, it was very, very hard to convince them to do it. And I'm kind of being unfair, and I'll tell you in a second why, because it's not that easy to check all of these things. So instead of kind of taking the time to get feedback about, yeah, what happened with my code, it was always moving on to the next task. And I have to admit, as a product manager, that I was a part of the problem as well, because unfortunately, organizations are very biased towards the next big feature, towards the shiny new thing. So as a product manager, my entire kind of, or how I was measured was, how can I advance the roadmap? How can I move things forward faster? As an engineer, I was measured by, how can I accelerate releases? How can I release features more often? And feedback is kind of in contradiction to that. So stopping collecting feedback, applying that feedback, that would actually be detrimental to that goal, right? We would actually be holding back this amazing roadmap, this important business goals, things we've committed to, because nobody was planning on getting feedback. And so it's kind of the last thing anybody wants in product management often, unfortunately. I say that with a lot of, I think it's wrong. And also from an engineering perspective, it takes time. It takes time to start collecting feedback, to understand what the feedback means. And it's often perceived as kind of going around looking for trouble that I might not want to involve myself in. But that feedback being very critical in production can actually come even earlier. So the more I thought about the problem, about Bill, the developer in my team, and getting him to get more feedback, the more I realized that we can actually use that much earlier in the process. So if you can imagine these feedback loops, some of them are when you code, others when you're running tests, production, all of these kind of loops have a lot of data in them, except that we're not using even a fragment of it. And it seemed to me that because this was the case, all we were kind of doing in accelerating releases was throwing features over the fence, maybe at a higher rate or a kind of faster velocity. And this was kind of confusing to me because, I'm a big believer, as I said, in best practices. I think, developers of all people should be kind of the most scientific in how they approach development. So how is it that, we discard the evidence and we just, keep on going to the next feature without actually seeing what we can learn from what we've done? So I looked to the basics, and there is this by now completely overused infinity diagram where, we can see all of the different stages of the DevOps loop, building, integrating, deploying, and operating. But there is something that, and this is just a diagram, I think it is the first one that you get when you search for the DevOps loop, and there are various other ones that all exhibit the same problem. But just by looking at it, does anybody notice anything that's a bit off about this diagram and the tools? Feel free to comment in the chat. So I'll give you a hint. It's right in the middle of the DevOps loop. And the problem is that there is a stage there. It says continuous feedback. It actually says that. It seems to be there to connect the data from operations back into coding. It's kind of the inverse pipeline to continuous integration. And yet the author of this particular diagram, for some reason, thought Salesforce was the right tool to put there. Regardless of that, notice how every other segment in the DevOps loop is full, kind of teeming with different tools and utilities and frameworks. And this one has only one, which is apparently the wrong one as well. So it seemed to me like if only we actually had that problem solved, if only we could have instant and objective data about the code so that Bill didn't need to think. He wants to know this code he rolled out, how is it working? Boom, he gets that information. The same time as he's developing, there is already data. Like, why not use that as well? I'm running the code locally, I'm debugging, I'm testing. There is a constant way to collect, or there should be a constant way to collect data and then use it as we develop to actually improve the code, to plan out code changes better because we understand the requirements. And this is a great segue to start talking about OpenTelemetry. So why is OpenTelemetry so meaningful? Why is it such a big deal? And I don't know who here, you can actually do kind of like a gesture or raise hands. I don't know if Zoom has that, but who here is familiar with OpenTelemetry or has used it in the past? Okay, several. So OpenTelemetry isn't a great revolution, or like it doesn't bring forward this new way of doing things that was never done before. It's actually rather an iteration on existing technologies. It kind of came about with the merging together of two previous standards, OpenTrace and OpenCensus. But it's still extremely important. And the reason that it's extremely important is first and foremost because everybody agrees on it. And that hasn't happened yet. So suddenly here is an open standard, completely free, managed by CNCF. In fact, it's kind of I think the most active CNCF project except for Kubernetes. And everybody is in agreement about it. And this is a great thing. And the reason it's so important is because it allows the support matrix to explode. Because right now, if I'm writing any library or framework, I don't need to think, well, should I support Datadog? Should I support maybe Grafana? Or maybe I should go with Splunk? There is one standard, and it's very easy to add kind of out-of-the-box support for it. And what that means for the end user is that when it comes the time to think about how to look at the code, how to collect data about the code, the batteries are already included because all of the frameworks that we use will already support OpenTelemetry, and it's kind of flipping an on switch rather than going into this project of changing the code and deciding what to collect. So out of the box, it doesn't matter if you're using Java Spring or Dropwiz or Quarkus or Micronaut, they all have out of the box support for OTEL. And it doesn't matter if you're using a Postgres database or if you're using Mongo or if you're using MySQL, they all of the libraries already have integration with OTEL. And it doesn't matter if you're using Kafka or Rabbit, they also support that. So as a result, we're seeing this amazing situation where it's very easy to just flip on that switch and suddenly our problem is becoming a different one. We're no longer running dark. We actually have a lot of data and a lot of visibility. And now the question is, how do we actually put it to use? So I do want to touch on one topic related to OpenTelemetry, which is tracing. So I don't know how many of you are familiar with the concept of tracing. Okay, cool. Anthony, you, Chris. Okay, yeah. quite a few. So I'll just do a very, very quick recap about kind of what is tracing and why it's and how it's useful for anybody who might not be familiar with it. So I'm going in this session, I'll soon switch to the code and show you kind of I was just using the Spring Pet Clinic app. And this is my setup. It's using an external API, it's using Postgres, it's using Spring. And a trace basically describes an entire flow. So user goes and accesses an endpoint, and then it does X, and then it does Y, and it talks to different services. This is basically a trace. It can also span multiple microservices because it is distributed, a trace. So it kind of propagates a context and allows you to see it all as one big trace, and you can see what was actually happening when the code was hit. At the same time, we have another concept called span, and a span is basically an activity within the trace that we can kind of highlight. And some of these will be generated automatically, as we'll see in a sec, because we're using a library that supports OpenTelemetry, and it automatically generates spans to describe the activities and save some data in there. And sometimes it will be, we can add them manually if we're adding some domain logic that we want to follow and keep track of and so on. And this is what a trace looks like in Jaeger, which is kind of a common open source tool to visualize it. And here you can kind of see what it looks like when I'm doing a get for a specific owner. And we'll take a look into that a little bit deeper in a second. But the important thing to notice is that there is information there both from manual spans that I've added, as well as automatic instrumentation through, in this case, Hibernate, Spring itself is contributing, and different libraries that I'm using are already adding a lot of data into the trace. Now, enabling OpenTelemetry is not something I'm going to do a rundown of for one reason. That area is well covered. So it's both, almost stupidly easy. In this case, you can see the code where it says export, where it's exporting the environment variables and running the Java app. This is everything you need to enable OpenTelemetry through the agent. There are various ways to enable OpenTelemetry for various frameworks. This is an example from the Java agent, which is kind of the simplest way, maybe not the most performant one. There are other ways like using micrometer trace, which is much more performant, but requires maybe a little bit more fiddling. But if you're getting started and you want to see kind of what is the value that you get out of it, even in testing and dev, where the performance hit won't be as meaningful, just run your app this way. No code changes necessary, which is amazing. So essentially, you set the agent path, you set the service name, basically describing your app, and then you run the app. That's it. Now, if you do want to look at a specific piece of code and add additional visibility, so basically create a span around that function and follow kind of what it's doing and whether, and having visibility into how much time it takes and so on, you can add the with span annotation that comes with OpenTelemetry. That does require adding an additional dependency, and that will immediately instrument your functions. So let's take a look at how we can actually use that in conjunction with open source toolings. And in this example, we'll look at Jaeger, we'll look at Grafana and Prometheus to see what kind of data we as Bill have now that we've rolled out our changes, and how can we actually look at our code and understand more from it, and kind of what are the changes that we needed to make. Does that make sense? Before I move on to the next section, is there any question? from anybody? Would love to answer. Okay, cool. So let's dive into the code. So here I have the Spring example. I've just added some more layers of functionality, so it's a bit more interesting to look at. It's currently running, and I can actually access it over here in my browser. And what I've done is I've added a collector, which is basically the OpenTelemetry way to get data and send it to multiple destinations, because I wanted to kind of use both a way to visualize the tracing and a way to go over the metrics. So I wanted all of these to be active at the same time. So let's start with the basics. So the basic is tracing, and I have here my Jaeger instance is open, and I'm looking at one of my requests. This is a request that has a get operation for an owner, and you can see here this is mostly things that came out of the box. So without me adding any additional information or code or spans. And the information that is available to me here can kind of, as the person who wrote this function, gives me a very good idea about where the time is being spent. So in this case, this is an API, a GET API. I can see the HTTP route. For each select, I can actually see the select statement itself. It's actually masked for sensitive values. It's running against Postgres, and I can kind of see an anatomy of a request. This is also where I can spot problems. So if the request is taking a little bit too much, and in this case, it's 186 milliseconds, it's not it's kind of slowish. It's something that I can debug and troubleshoot and see what I need to solve, which specific area is kind of holding back the request, and so on. Another interesting
question for Navid. I'm sorry if I butcher the name, but I think he's talking about the instrumentation agent. Does it work with Reactor, which also means, like, does it work with a web flux and things like that, or does it need to be synchronous?
Oh, yeah, you mean if you're using a reactive way of development?
Yeah, I think the Reactor is the underlying reactive framework.
So it depends on the framework and library. For example, if you're using Quarkus and you're using their reactive way, then you should use their OpenTelemetry extension and not the agent. The agent is a great kind of way to enable OpenTelemetry really quickly on simple code. If you're using specific libraries, you might want to look at what they recommend. So as I mentioned, like Quarkus does this. It can generate the trace even if it's created, with a thread pool and a reactive extension, but you need to use their OpenTelemetry extension instead. And by the way, that's another kind of benefit to using OpenTelemetry, that all of these libraries and frameworks are actively busy improving support and making sure that it works and both in reactive, non-reactive. These are the sort of things that until now those who try to do them were mostly the APM vendors. Make sense? Does that answer the question? Okay, cool. Great. Let's take a look at additional tooling that we can actually configure. So actually wanting to bootstrap this for a second. So let me enable my plugin. This is just a my quick way of enabling OTEL. And then let's take a look at some of the metrics and how it's possible to use them. But then after that, what is more interesting to me is I want to take a look at how I can actually take my work and all of the changes that I did and actually see how I can find out things about the code, because this is kind of what we were missing, right? So the problem originated with a developer having no feedback. Let's say I added this kind of adding a new owner functionality, awesome, and I've added some logic to it, and I have no feedback right now about you know, whether my code worked, whether it's good, whether it's bad, kind of what's going on there, right? And this is kind of what I'm going to try and find out now. So without further ado, let's try to explore a few functionality that's available here to me with Jaeger. One of the things that I can do, which is really neat, let's take a look at maybe a short duration, okay, is I can take two traces, let's say before and after I made a change, and I can actually compare them. And this is interesting because if there is a difference in them, in this case, they're identical, but if I've added something that added more duration, or that added a different error, or there are different new spans or spans that were removed, it's a nice way to take a look at the before and after of the request. At the same time, if I added a piece of functionality, I would usually want to kind of see that I can actually see that in the trace. But to do that, I might want to add an additional kind of way to, like a whiz span, for example, annotation, in order for me to be able to see that information over here in the Jaeger view. So like talking about kind of the, yeah, I think I have that here. So talking about kind of the naive case that we talked about before, about the developer not necessarily knowing that his code is even being used, this is where you can actually pull up the trace from production, from dev, and see, kind of find your specific piece of code that was used and make sure that it was actually being called or triggered. The other piece that we have, and that is also kind of interesting. Oh, and by the way, you can notice that this actually gives me an interesting way to scan all of the different traces by duration. So I can see, okay, this call was relatively taking a lot of time. What's going on here? And suddenly we can kind of see that, yeah, there is a lot that was going on in this request. So it's very easy to spot whether, you know, something was a bit off. In this case, it's kind of the post request. So we can kind of take a look at that specific request and see, okay, is this an anomaly? We can see there are like 401 spans or 442 spans in the different requests. So it's taking obviously a lot of time. And if we can compare them, we can actually kind of see what are the things that are different, that are changing between them. And this gives us a great way to kind of start diving into the code and understanding more about what was good or bad about my changes. The other way that we can harvest that data is using metrics. And to add metrics, I had to add, again, a few dependencies. In this case, I'm using Spring, so I had to use the actuator as well as micrometer Prometheus package. So 2 dependencies, and basically that's it. And now when I kind of look at, let's take a look at Grafana, which is a great way to look at the metrics. I can actually connect that to my Prometheus instance. Let's do that right now. And the nice thing is, this is open source and free as well, like everything I'll show you. And the nice thing about this is that there are a lot of kind of prepared dashboards that you can download for any framework. If you're using Quarkus, if you're using Micronaut, if you're using Spring, all of them kind of have dashboards that are very easy to import. So you can import it from their marketplace. In this case, I think I created one or imported one myself, and immediately, you know, without, again, any code changes, I can start seeing metrics about my code. In this case, this is my local environment, but even here, if I make drastic code changes or I make like a refactoring and I want to test it out, it's a good idea to roll out the new changes, run them, and then see if we have any changes in the graph that would indicate a problem. So I'm actually not going to, again, do a tutorial about how to set up all of these tools, just because it's very, very simple. And I frankly don't have much to contribute. Most of it is just running a Docker container, and that's it. One thing that I do want to mention is that OpenTelemetry does have this neat thing called a collector. And a collector is essentially like a router for all of the observability things. So you don't need to have one. If you're only sending your data one place, then you don't need a collector, you don't need a router. But in this case, I already have Jaeger and I have Prometheus, and I want to make sure that I can configure what the data pipeline looks like. And the nice thing is that it's also completely outside, you know, the code. It's just a container with a YAML config file that I can set up whichever way I want in order for that in order to get all of the information in the right place. And it supports things like sampling to kind of help with the performance and kind of other really neat features that are very production ready. So it can really scale well. So just to show you, this is kind of my current config file. And all it does is it specifies the different endpoints. This is the Jaeger, this is the Prometheus, and what the pipeline looks like for tracing, in this case, for matrix, like where do I want to send that information. So it's kind of one YAML file, very easy to set up. Just specify the number of tools that you want to use, which order to send it to, and then if you need to do any pre-processing. So all of this is great, really. It's not a big deal. It's not a hassle to configure these, to use these. But it's not helpful. And I say that having used all of these tools together for a while. And does anybody have an idea why it's not that helpful?
Because someone still has to manually collect all of this information on an instant, and trace back to the changes, right? Would be my main guess.
Yeah, this is amazing, right? We didn't have that data before. Now it's great and easy to collect it. That's great. But we have, you're right, we have created ourselves more work because having data is not enough. You know, having data about the code is just data, right? You still need to process it to figure out what the data means. What I showed you was individual traces. How many individual traces can we review in one day? Like, that doesn't make sense. So when I went back to Bill and I told him, hey, look, here's the data, now use it, we got into a really long discussion about how to remove outliers in the best way and how to do a regression and how do we know whether this is significant or not. And we were going back to statistics and doing some basic data science and going through all of these motions just to find out the answer to those very simple questions that we started from, like, you know, did my code work? Did it improve things for everyone? But then, you know, the data is so noisy, how can you even tell? So, and I also want to tell you another story that happened at somewhere around that time. And that story is kind of about the concept of a 10x developer. So I don't know kind of how many of you believe in the 10x developers. I've definitely met developers that were awesome. They were great. They were very talented. I actually met a 10x engineer a while back who, and he was really, I think, borderline savant and really awesome with code. He would not debug at all. He would just write code all day long. And then if he made a mistake, he would just delete everything and write everything again. And he would still kind of, it would work like the first time he ran it, as if he was debugging it in his head. And he would like complete tasks at a fraction of the time of everybody else. I would actually find him with a thesaurus in his hand for hours. And I'm asking him, you know, what about the task? And he said, yeah, I completed it like after 5 minutes, and now I'm just looking for class names in the thesaurus or something. He was really awesome. At the same time, nobody could use his code because it was so dense and nobody could understand it but him. And he also, you know, eventually when it came to the actual contribution, while he might have been a 10x engineer, it was very difficult still. And when you looked at the overall kind of contribution to the product and the pipeline, it wasn't the 10x contribution. It just meant that he wrote code faster, but that's, you know, just a small part of it. But then I had another person in my team. And this was actually a little more than a year ago. And that person had, for some reason, decided to add some console logging. We had a background process that we were monitoring, and he just added a console log for each iteration to know how much kind of the entire loop of handling the events was taking. And, you know, this was creating a lot of hassle for everyone. It was suddenly flooding the logs and kind of, and nobody was understanding what he was trying to do there. So I asked him, you know, what's going on? Why are you doing that? Why are you printing the duration to the screen at all times? And he said, well, as I make changes, I want to notice visually when I have a regression, when I add another line of code that is slowing everything down. Now, obviously, this is not the right way to do it, but if anything, it just points out a tooling problem rather than an intent problem, because I had many developers in the team. None of them thought to even check anything like that. So if you go back to Bill, everybody there were similar to Bill. They were completing their task, moving on to the next item in the backlog. But for some reason, he actually had that. To me, that's the next X, which is his ownership was not about throwing a code over the fence, was how do I actually make sure that he runs? And he's thinking, his head was in the right place, because it has to start with the data. So I asked you before, what is your opinion about why isn't everyone yet kind of using continuous feedback, using all of that data from OpenTelemetry? And I think we've uncovered that and everything you said right now was very true. So you talked about kind of the fact that you need to manually do it, and you need expertise, and you need statistics. I'm myself, kind of my weak spot or my Achilles' heel is actually doing house repairs. So I would never do house repairs unless circumstances completely make me do it. Otherwise, I would just procrastinate or kind of postpone it as much as possible. And if I'm a developer and I'm not a statistics expert, and there is this pile of data here, I would probably procrastinate that as well. Context switching is a big thing, and it doesn't help, as we talked about before, that the entire organization is very forward leaning and everybody wants to get to the next feature. But the more fundamental problem, I think, is the same problem that, if you look back at testing, was kind of make or break in making tests a part of the DevOps process. And that is them being continuous. Before tests were continuous, when we actually relied on the goodwill of the developer to remember to run his tests every now and then, that system could never work. Like, yes, some developers were practicing TDD and very, very kind of disciplined about running tests all the time. Awesome. But before we made that a part of the CI, something that happens automatically, something that you don't need to think about that, it didn't actually scale in the organization. This is exactly kind of where my own personal journey with continuous feedback started a while back. So I was seeing everything that we're just talking about and thinking, how can we actually make that into something impactful that is automatic, that is continuous, and that solves that expertise problem? Because frankly, this problem is absurd, right? We have AIs that can generate code amazingly well. We have data science that can solve much harder problems, than finding the kinks in the graph, or understanding why some behavior changes happen that I need to notice. And still, as developers, while all of that data exists, it somehow isn't something that we use a lot. And I talked to many organizations over the last year, and to many developers specifically, and many of them actually use all of the tools that I just mentioned, but they don't use them. They kind of have them. And the objective for all of these organizations and all of these projects was, how can we get observability? So the thinking was a bit skewed, because the end result is not to have an amazing observability framework. It is not to have this top-notch dashboards or shiny graphs, or have a very effective observability project that covers everything. The end results needs to be, how do we actually take that and use that in our dev? How do we use observability to improve the dev process, or to make our code better? And you can't actually do that without taking all of that data and seeing how to translate it to code. Because at the end of the day, while there are many tools that look at the service level and the APIs and maybe allow you to drill down into specific areas, if they're not integrated into my code flow, if they're not a part of my GitOps, if they're not in my field of vision as a developer, if it requires me to go and manually check some dashboards randomly, then they just don't work. And this is something that we've seen consistently. So I want to show you kind of like a glimpse of how I think about it. As I mentioned, all of the tools that I'm showing you today, including Digma, are free. And I'm not even, the reason that I'm showing Digma right now is more to talk about kind of the vision or how I envision being able to work with this data in the future. And there are other tools that are being developed that are trying to do the same thing, and I'm absolutely glad for it. Most of them are proprietary, but still, I think that any organization that will adopt them will see a lot of benefit, both in code quality as well as in solving, detecting issues much earlier, as well as actually improving our quality of life as developers, especially as code becomes more complex. And we're dealing with code that was either AI generated or generated by our peers and so on. So looking at the same data that we looked at before, I'm going to go back into my code and kind of take a look at what just happened. And everything that Digma does is essentially take the data that we've seen before and learn from it what it means about my code. So I can go to any specific code location and just see what is happening there in the different environment. This is my local environment. I have a load test environment and some other environments that I can look at. So in here, I could have gotten there in the same way had I analyzed all of these traces or looked at the graphs long enough and hard enough until I kind of start seeing them in 3D. But in this case, all I did was just actually do that for me. And the idea is, how can we really create an experience where it just happens automatically? And here I can actually see, okay, there is a problem there, and that's kind of like a suspected N+1 issue. And this is where it's happening in the validate owner function. And I can actually go there and see, where is that problem happening? What is the query that is being repeated? And take a look at the trace. Sorry, this is just my local environment. But basically go to that trace where this issue is currently happening. At the same time, I can go into that piece of code and see who's using it. Again, this is like these paths, or the usage, the runtime usage of this function is something that I could discern if I played around with Jaeger long enough. It would just take me a lot of time. And if I want to make sure that I don't break things for somebody else, then that's kind of like a very easy way to go about doing the same thing. So the idea is, how can we take something that is very dense with a lot of data points, and how can we actually distill from it the specific things that we need to know about, this area in the code? We can kind of track the execution of this specific area in the code. And all we're doing is not generating any new data, but just using the same data that was there all along, in order to be able to look and understand the code a little bit better and find out things, even in dev, as we're introducing code smells, or as we're looking at different errors that are happening or any regressions, and being able to kind of act on them and get that feedback loop into something that's much, much closer to the dev process. And what that means is that Bill, when he is able to start any tool like this, any tool that looks at the OpenTelemetry data and tries to process it and bring it back to the IDE, he can actually now not have to have me chasing him around. Did you check it? Did you check that? And if his code was actually never reached, he'll be able to see that it was actually never reached because he made that bad if statement or whatever. So this is the kind of experience that would be able, or that would allow us to make development much, much more effective and efficient, and actually solve a lot of the issues that we're having today, because we're unable to actually just spend the cognitive effort required to translate these observability data points the raw data into something that's more useful.
Quick question, Roni, that N+1 suspect warning there, did you mark this manually, or did it seem that there's too many database calls, or did it auto detect an N+1 problem?
It detected exactly, and there are many other things that are being detected, like scaling issues, like connection tool problems, like different errors that are escalating. And the idea is, how can we actually make that information also kind of available across multiple environments and so on?
Do you do any sort of like code analysis, like, okay, you have a new deployment, there's a new piece of code, there are new exceptions happening, so this is likely the culprit of the problem, or not yet?
Yeah, we're doing a lot of root cause analysis based on code changes and things like that, if that is the question.
Thank you.
Any other question? So the important thing is that Sigma is currently in beta, and it's a new project. It's free for developers. It is something that we're testing out, and it's in those exciting stages where we're learning what's important, what's useful, and how to improve our value. At the same time, we're looking for people to join the beta program. It's actually publicly available. You can get it. It's just an IntelliJ plugin, really. And it's also running locally, so it doesn't share any data to us, if that's a concern. And one of the things that we're looking for are people to experiment with it, see if it brings them value, if it actually, it's a great opportunity to learn more about OpenTelemetry and see how it works. But one of the nice things is that Sigma configures OTEL for you, so you don't need to worry about any of the things that I just showed you about collectors and adding dependencies and whatnot. You just turn on kind of an on-off switch, which is essentially right kind of was the vision with OpenTelemetry. So essentially you can turn it on and off, and whenever you turn it on, then it will just configure everything for you without any code changes, so that you can take and ingest the data and start processing it and seeing what the results are, and understanding kind of what it tells you about your code changes. Where are the bottlenecks? Where are the weak areas? What are the things that have changed? Catch on kind of on any things that you may have inadvertently added to the code base, and then have that kind of as your own personal assistant, looking at the runtime data behind or over your shoulders to kind of alert you to any issues. So we'd be extremely happy for anybody who wants to join the beta program. Just go to digma.ai/beta and let us know your thoughts. Okay, so we have some time for questions. I see there is one with regard to Digma, or even more generally the OTEL. Is it possible to use that within continuous integration that checks traces against specific SLAs, for example, and fail to build if numbers are worse, so we can prevent problems before it happens? Yeah, definitely, and that's a great use case. We're actually right now working on our GitHub application. So this kind of idea is really helpful. The GitHub application has pull request checks, so you can actually have these kind of thresholds that you'll be monitoring. What is even more interesting than having a threshold is being able to kind of find the change that led to that specific issue. And this is also something that we can do with a little bit of data science magic where we can say, okay, the anomaly in the graph begins here. These are the commits that may be related in terms of the location, and this is what you should be looking at to solve the problem. And by the way, sometimes the issues are circumstantial. So, for example, one of the early things that we had to do that everybody who deals with data needs to know how to do is kind of find out which variables are correlated. So, for example, is the reason this is slow because it's slow, or because there is high concurrency and there's a lock or critical section out there? Or is the reason that the CPU is too high and the system isn't getting enough resources? So kind of understanding the root cause. It's not always about the code. It's also knowing when it is actually about the environment.
I just want everyone's feel free to unmute if you have any questions, but I just want to give a massive shout out to Ronnie. It's a very interesting tool in a way. Like I don't know about everyone else, but I want to look under the hood and understand, okay, how you're connecting all of this data and how we're getting these insights. Maybe material for another talk one of these days. A very, very nice talk, Ronnie. Thank you very much for your time with us. I'll just open for questions, but just a quick one. The video will be available at the London Java Community channel in about 48 hours, if anyone wants to watch it again. Okay. Cheers, Ronnie. Thank you very much.
Thank you, everyone. And please be sure to check it out. Even if you don't want to be a part of the demo, you can just install it from the marketplace. Thanks, everyone.